Hi everyone. So now I want to go over the two-way set associative cache, especially the example that was in the exam review. Okay. So as you know from the question that we have every set has two blocks. Okay. And we have two sets in the cache. Okay. So every set has two blocks and we have two sets in the cache. So this means how many blocks I have in total. This means I have 4 blocks in total, okay? And to represent each bit for the word, we know that from the previous example, so it's a byte addressable. So we need 3 bits for the word, okay, as you already know. So we need 3 bits for the word, and we need one only bit for the cache, for the set, because we have two sets only, okay? I have set 0 and set 1, so we can just represent them using 1 bit is enough. The rest of the bits are for the tag, okay? So same as in the previous example for the full associative cache, the dirty bit remains 0, as we said in this example, because we are just reading values. This will become 0. This is 0. This is 0. And this one. Okay. There are no valid tags at the beginning. No tags are valid. So the valid bit initially is equal to 0. Okay, so this is 0. This is 0. This is 0. And this is 0. Okay. Now we need to start with the first address. Okay. So we'll write it here. The first address is 200. Okay. And as we established in the previous example, that the entire block has to be fetched if it's a miss. Okay, not just the entire block here means the data in this block. So we will get A and also, okay, so 200 because there were no valid tags at the beginning. This means that it's a miss. Okay, so we will bring the entire block. Okay, so A and B, these two, they will go to Z set 0. How do I know? Because when we write the address, the binary address for the 200, okay, you can see here this is the set bit, okay, so it is 0, okay. So A and B, both of them will go to set 0, okay. So let's put them here. So A will go here, and B will go here, okay. Because this is the free block, the first available block in set 0, right? So that's why we are putting things first into this one, okay. What about the counter? Will it change? Yeah, the counter will be initialized into the 0 because this is the most recently used one. Okay, so this one will be 0. Okay, and the tag, of course, the valid bit now will become 1. Okay, so now this will change into 1. And then we have to place the tag right there. Okay, so we write the tag, as you may know. So it is 0, 0, 1, 0, 1, 2, 3, 4. Okay, so this is my tag. Anything else? No. So this is good. Let's move to the next address, 204. Okay, so now we move to address 204. Okay, so if we write the corresponding tag to this address, we'll find that it's actually the same like this one. Okay, so if I search all the tags in the cache, so it will match this one. Okay, so this means it's a hit. So I will write it here. So it's a hit. Okay, the counter is already set to 0, so no change here. Okay, let's move to the next address, which is 208. Okay, so based on the tag or the address of this bit of the 208, as you may see, this one, and the set and the bit for the set. Okay, so the bit of the set here is showing as 1. Okay, so this needs to go to set 1. Okay, it needs to go to set 1. Where is set 1? It's here. Do I have any matching tags to this one? Actually, nothing is there right now in set 1, right? So this means that 208 is actually a miss, right? So 208 is a miss, correct? Okay, so what shall we do now? This is a miss. We need to bring the entire block, okay, from the memory into set 1, okay? Where is the entire block? So I'm talking now about address 208. So this is the entire block here involved in this address, okay? So I need to get this whole thing, okay, and place it into set 1, okay? So set 1 is here. Which location shall I put it at? Okay, the first free block, the first available one, okay? So let me put C and D. So C will go here, and D will be placed here. Just need to move it because Paint does not provide like full control. Okay, and what about the counters? Okay, so pay attention to something here. Okay, in the set associative cache, every set is an individual unit. Every set works on its own. Means that it has its own counter. It doesn't affect other counters in other sets. Doesn't care about other sets. Okay, so it only looks or has an access to its own set. Okay, so if I have a counter in set 1, it doesn't care about what is happening in set 2. Okay, so that's the rule here. Okay, so what will happen? So this is the most recently used value now, right? It's here. So what will happen? The counter will be 0. Okay, does it care about the other counter, which is this one? No, it doesn't care. Okay, because it is in a different set. Okay, okay, what about the next address? Okay, I have the next address, which is 20C. Okay, so to get the tag, okay, so oh, I didn't place the tag here for this one. Let me do it. And also I need to change the V. This one was 0, 0, 1, 0, right? So C and D is 208, so 0, 0, 1, 0, and then 0, 0, 0, 0. Okay, and then I have also the one which corresponds to the set. Okay, okay, so I'm done with this one. Now I need to move the V. Let's update the V as well. The V also here comes 1. It's now valid. Okay, so let's write the next address. Okay, next address is 20C. 20C. Okay, 20C has to go into set 1, and also you see it is the same tag. It is, if you search all the tags available, it is matching this one. Okay, so it's a hit. So it's a hit now. Let's write this down. This is a hit. Okay, but do we need to update the counter? Okay, hold on. The meeting will end. Need to refresh. Do I need to change the counter? Okay. The counter here is 0, right? So there is no change. No change at this point. Okay. Let's move to the next address, which is 2F4. 2F4. Okay. If I get the corresponding, let's write this down here. Corresponding binary value to F4 equal, okay, it's equal to 0, 0, uh, 1, 0, 0. Okay. So does this address is it available anywhere here? Okay. And if we look into the set as well, it goes to set 0. So in set 0, do I see anything similar? Okay. No, it's not matching, right? It's not matching. This means that this is a miss. This is what? This is a miss. Okay. So because the tag does not match the tag in set 0. Remember here, remember that every set works on its own. Every set is an individual unit. Okay. Okay. So this is a miss. We need to do something, right? So this is 2F4. Let's look into the table here or into the memory. 2F4, where is it? It's here. I need to bring what? I need to bring the entire block. Okay, I need to bring the entire block from the memory. Okay, so where shall I put it? So based on this set, it is saying that it should go to set 0. Okay, so of course, the available spot is here. Okay, this is the available block. Okay, so I will place K. K will go here, and L go here. Okay, perfect. Okay, is there anything else I have to do? Yeah, for sure. Okay, first of all, I need to change the V into 1. I need to place the tag here. Let me put the tag. Okay, so this will become 0, 0, 0. Okay, anything else that has to be done? Did we forget anything? Yeah, of course. What about the counters? We need to change the counters. Okay, so what are the values that we have to place? Okay, so now this is the most uh, recently used one, right? So this will become 0. Agree? Okay. What about the other counters? So I need to increment the counter in the same set. Okay, only the one in the same set. Okay, so this one I will have to this one change into 1. Okay, I think looks good. Yeah, things are good. Okay, let's go to the next value, to the next address, which is 2F0. Okay, 2F0. What about the tag for 2F0? Because we need to decide whether it's a hit or a miss. Okay, so let's try 2F0. 2F0. We did that already before, but it's fine. So it is 2. Okay, and then we have the F. Then we have the 0. Right? Okay. So is this available anywhere? Yeah, develop. Okay, so it is also same to this one. Okay, so this is a hit. This is a hit. Okay, so here, but do I need to change the counter? The counter doesn't change, right? Because it is already 0. Okay, so no change. Let's move to the next address. Next address is we are going back to 200. Going back to 200. Okay, so this means obviously it's a hit, right? So this is a hit. Okay, so is that it? No, I need to do some changes, right? What are those changes? Okay, so now this becomes the most recently visited or the most recently used. What shall I do here? Let me put a line and I need to reset the counter, okay, into 0. Now the counter will be reset as 0. What about the other one in the same set? This has to be incremented into 1. Okay, do I change that? No, I don't change this. Okay, okay. Let's go to the next address, which is also 204, which was visited before. 204, okay, and of course it's a hit. Okay, so this is a hit. And where is it located? It's located also in the first block here. It's located here. Okay, so the counter is already reset, right? So no change, no change. Okay, let's go to the next address, which is 218. Okay, 218. If you write the corresponding value here, let's write it down. It, and this is corresponding to okay. Let's see if it's a hit or a miss. So the address here tells me that it has to go to which set. Here I have a pen. You see here, it has to go to set number 1. Okay, set 1. Okay. Do I see any similar address or similar tag in set 1 here? No, I don't see, right? This means that it's a hit or that's a miss. Okay, this means it's a miss. What shall I do if it's a miss? Okay, so we need to copy all the blocks and increment other counters in the same cell. Okay, so let's see what we do. So we have here a place that is empty, right? We have a place that is empty. Okay, so this goes to set 1, so it will go to this empty place. That's the only one available. Okay, so this means 218 is a miss. We said that already. The cache here will look like this, will stay the same, and we'll just write whatever was there. So 218 has G and H, okay, because we need to move the entire block, data in the entire block. So I place here G and H. Okay, okay, very good. Do I need to change anything? Yeah, for sure. What else do I need to change? This one. Change to 1. Tag. Okay, let me put the tag. Anything else that I have to place? And anything else I have to change? Okay, so now the counters, this one becomes the most recently used one. Okay, what else? Do I need to change anything in the other? Let's say here. No, I don't change anything. This is a different set. Okay, remember, this is a different set. So I can change, of course, this one, right? So instead of having this one, let's try different color. This one will become, I will scribble this, and this will be the new value as 1. Okay, okay, very good. Okay, let's move to the next address. What is the next address here? So I have 21C, 21C, 1C. Okay, 21C. Where is it located? Okay, 21C, which had the H, here. Okay, so it is a hit. This means it's a hit. Okay, and of course, because this was the most recently used one, so of course the counter doesn't change. Okay, I don't change the counter. Okay, stays the same. What about next one? So next address, I have 24C. Okay, 24C. To get the corresponding tag, okay, we write this black. Okay, to 24C equal 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0. Okay. It shows which set I have to use. It shows set 1, right? Where is set 1? It's here. Oh, I don't have any room. Get another value. Set 1 is full. So what shall I do? I have to overwrite, right? So 24C is right there. This is 24C. So I need to bring the entire block, which has N and R. Where is it going? It has to go into set 1. Okay, so it will go here. And of course, it will go where the highest counter. Okay, the highest counter. So it will go to this location here. So instead of C and D, I will have N and R. This is N. And this is R. Okay. And what about the others? What about the other counters? Okay. What will happen? So this one, because this is the most used one now. Okay. So I will have to reset the counter. This one has to be reset instead of 1. It will become 0, right? It's not writing. It looks horrible, but it's fine. And this one in the same set will be incremented by 1. Okay. Okay. And let's try the next address. Oh, so 24C was a hit or a miss? Okay. It was a miss, right? So let me write this down. Okay. What about the next one, which is 2F4? This is the last one finally. Okay. 2F4. Okay, 2F4. Check 2F4. Let's write the address. 2F4 equal. Okay, so 2 okay, and then F, and then 4. Does it match anything from before? Yeah, it actually does. Okay, it actually does match that one in L. Okay, it matches this one. So what shall we do? I need to reset the counter here into 0, right? Because now this is um, most recently used. Okay, so this counter right there, this one will become 0. And how about the ones in the next, in the same set? This one will become 1. Okay, do I have to touch anything here? Okay, no change. Okay, no change right here. Okay, so I have to write here. So this is 2 F4. This is a hit. This was a hit. Okay, done. Am I done? Yeah, we're done. Okay, we finished. So also we need to calculate the count heat rate. We can do that as well. So 1, 2, 3, 4, 5, 6, 7. Okay, so same as the previous one. So the heat rate is 7 over 2. Okay. Thank you everyone so much for your time and have a good rest of your day.